Let's discuss the agenda of today's class. So, we'll just introduce AI briefly and then tell the challenges and benefits of using AI in cybersecurity. Then, our custom course that we have, AI powered cybersecurity, will dive deep into the domains. So, you'll not just come to know about the course, you'll come to know exactly what to study, that which all topics you should focus on. So, all those who are interested in joining the course, you're always welcome. All those due to some reason, if you're not able to afford, or if you don't want to study by an instructor, if you want to self study, then today's class will also be beneficial for you because you will know all the topics that you need to focus on, right? Then we'll tell you that what are the prerequisites for our course, who can take this course, and of course, the industry demands, career opportunities of combining AI with cybersecurity. That will also be covered here. Then I'll just give you a quick preview in the end of this machine learning lifecycle, how ML is implemented in organizations and how this ML ops takes place, right? And then we'll also have a question answer session. If you have any doubts related to the class, related to the course, you can ask that in the end. So let's begin. Let's introduce this AI powered cybersecurity. And initially, what we'll do is we'll begin with what is this AI? What is artificial intelligence? Artificial intelligence now, it is all around us. It is like recommending you your next video. It is even chatting with you and it is even driving your cars. So the question it comes here that what is this exactly? What is artificial intelligence? So as you can see, this gentleman here, John McCarthy, he had described this AI, he had defined it long back in 1964 itself, because as you know, computer systems, they were developed long back in the 20th century, initial 20th century, right? So he described this as the science and engineering of making intelligent machines. Yeah, you'll get a certificate after you complete the session. Once you fill the feedback form that we'll be providing in the end, once you fill that, then you'll be getting that. So this John McCarthy, he described this as the science and engineering of making intelligent machines. So what are these intelligent machines? What do we mean by this? So any machine that has human-like processing, that can do human-like processing, that are our intelligent machines. So by human-like processing, I mean that it can understand language, speech, and visual information too. Now, how does this happen? This happens because these AI systems have the ability to recognize patterns. They have this ability to recognize patterns in data that is provided to them. So as you can see here, it's identifying patterns and trends in large amounts of data, right? And based on this pattern recognition, it is able to do this problem solving tasks. It is able to solve the problems. And if you will ask me in one word that what is describing this artificial intelligence, how it is different. So any system that has the ability to learn and adapt, right? It can work on new data, isn't it? So that this is our most crucial aspect of artificial intelligence. So now this AI, it is such a field that it is multidisciplinary in nature. It combines computer science, data and algorithms. It combines even mathematics, statistics. And since we are going for this human-like processing, we are even combining these cognitive sciences, the sciences related to a human brain and human mind, right? This is there in this. So now when we proceed further, yes. So when you're going for traditional programming, here you can say this is only rule based. See, if you know that basics, like you must have taken a programming class, you know this if else rules, right? You have these if else rules. So it can only work on that kind of data that is present in its database, this coding database. It cannot work on new data. Your traditional programming can't work on new data. So if I want to explain this with an analogy, you consider this traditional programming as a person who is just performing this rote learning, or he is mugging up something, right? Learning it by heart, and in the next day, he just writes it down in his exam, in his answer sheet. He writes down all the answer, and then after that, he forgets everything, right? So he's not working smart, right? He just knows about that thing, that what he has learned, and then if anything comes from outside of what he has mug up, he won't be able to do that, right? But if you consider this are AI systems, they use machine learning, right? They use this machine learning, and due to this, they identify the patterns in the data, right? They'll identify these patterns in this data. And this machine learning is like a student who studies in such a way with such an interest that he doesn't studies just for the sake of passing the exam or getting good marks. He studies for the sake of learning and applying what he has learned in real life, right? This is the difference we see here. So if you see this flow chart, you will just study the problem statement in traditional programming. Then you'll write down this your code, your if else loop inside a for loop or while loop, right? Then you'll evaluate it whether it is working, whether there are syntax errors or logical errors. If there are errors, you'll analyze these errors, repeat the process again, and once it is working, you can launch it in the real world. But it will not work on new data. But now someone is asking, Gaurav is asking, what is new data? So by new data, we mean, so see, one is your training data, right? Which the model has seen, is aware about that, isn't it? Or if you're considering this traditional programming, so the data that you have fed in this database, right? It can only read that from that database. But if it gets that new data in real world, so see, if you are working with if you are analyzing that network, your network traffic, and if you want to search for DOS attacks that are taking place. So new types of DOS attacks that will come in your organization, isn't that an example of new data, right? That is an example of new data. So if you are just going by rule based, so rule based coding that you are integrating with your SIEM tools in your security operations center, your traditional programming can only identify the existing ones. It cannot identify new types of attacks. But if you are training your machine learning model in such a way that it identifies these patterns, it will identify these patterns in this data such that whenever if new data comes in the real world, it can still figure out whether this traffic is normal traffic or anomalous traffic. Both things can be figured out here. So here what happens, you study the problem, you train the machine learning model, then you evaluate it by testing on this existing data. If it is not working properly, you'll analyze the errors, you'll retrain the model till it is working properly, and then finally you will launch this, right? So now we see this development of AI. So initially, we had only rule-based artificial intelligence. So these scientists, data scientists, and ML engineers, they tried to create. So at that time, we had only computer scientists. They tried to create such a model, artificially intelligent model, by creating all the rules in a large amount of database you had there. But again, if that new data that is coming, it exists inside this database, it will work. If it doesn't exist, then it won't work. So this was not so effective. But then we came to machine learning. So this machine learning, it has the ability to learn without being explicitly programmed. So explicitly programmed means for that particular task, programmed for that particular task. So the programming and coding is taking place, but it is just taking place to train the machine learning model. Once you're working with new data, then that further programming is not required, right? The machine is learning on itself, isn't it? Then in our 2010s, this is our latest technology, we have this deep learning here, right? So can anyone tell how is data science and artificial intelligence related? Yes, so you're using data science techniques in artificial intelligence, right? You're feeding it data, right? So you need to clean this data, you need to modify it so our machine learning models can use, isn't it? So that is how this data science is related to our artificial intelligence. And artificial intelligence is run by your machine learning algorithms. So this is how they're related. And inside this machine learning also, we have our deep learning. So deep learning is a specific type of machine learning. Okay. So this deep learning, it is modeled, it is inspired by the human brain. Okay. And what is the building block of human brain? Right? So just like our neurons, like they have your input layer, hidden layer, and output layer. Same way, these artificial neural networks also, ANNs, they are designed to work in such a way, right? So now if you look at this AI learning types, there are different learning types. So you must have heard about this machine learning also, deep learning also. But I'll tell you all the different learning types that are possible over here. Okay. So first you have this supervised learning. So in supervised learning, there is actually a human operator there who looks at the data. Okay, he will look at this data, entire data, and then he will flag it that whether it is, he'll label the data as 1 or 0 that way, right? So say if you're looking at anomalous network traffic data, so if it is anomalous, he'll label it as 1, right? Because machines, they understand numbers better than words, right? So he will label them as 1, 0 as normal data. Okay, that will be there. So, or you can take that example of phishing emails also. If it's a phishing email, he'll label it as 1, he'll see it. If it is not phishing email, he'll label it as 0. So that is there in this. So you have an Excel sheet or in CSV format, you have that, and there you label this. Okay. So this is how your supervised learning works. Based on this label data, your machine learning algorithm will come to know whether this particular data, he'll find out the pattern. Okay, this is the pattern of a phishing mail, and this is the pattern of a normal mail. So next time when you're working with new data, okay, so this is your training data, and when you're working with new data in the real world, when you have integrated this with your SIM tool, SIM solutions, or your email clients, if you have integrated this model there, Then whenever a new phishing mail or a network attack comes in, so you'll come to know, okay, this was the particular pattern of a phishing mail or a network attack. So this will automatically flag that as malicious and raise the alerts. Got it? How this supervised learning is working? Then next you have this unsupervised learning. Now in this was about supervised learning. Okay, so if you want to apply this for our cybersecurity applications, so you can use this for classification tasks, whether you're detecting a malware, anomalous network traffic, or phishing mails. Okay. Now, if you come to this unsupervised learning, just imagine you have a cupboard here. Yes, this is one particular algorithm there, clustering. So after washing your clothes, you have just crumpled them. Your shorts, your shirts, suits, everything, they are crumpled up, right? Now what you do, you will see this, you will see the pattern there that, okay, the short looks like this, shirt looks like this, right? And accordingly, you will arrange them, arrange them in one place, right? In your shelves. So what happens in this machine learning, we are using this statistics and probability, right? You're using statistical approach, and in this embedding space that we have, so a graph will be created, right? There it will first it will identify this new data as an unknown data, because it is unlike supervised, it has not been trained before. It has not been trained on this labeled one. A human operator is not there. We are not telling this ones and zeros. We are not telling the machine learning model that what is anomalous and what is normal. Instead, so see, if it is DOS attacks, so in DOS attack, how will you identify that DOS attack? What different pattern will be there in a DOS attack? Anyone? From normal data and DOS attack, what kind of different pattern can this machine learning algorithm, this unsupervised machine learning algorithm we have, what kind of pattern can it find out over here? Number of packets coming per second, can I say? Right? This can be one pattern over there. So amongst many others, right? So it will see this pattern, and in this mathematical, this coordinate space over here, it will just cluster one kind of data in one place, and it would cluster the other kind of data in another place, right? So this is how our unsupervised learning is working. Okay. Yes, we can also identify this pattern of buffer overflow. Now coming to this reinforcement learning, what is this here? So this one, and see this unsupervised learning, because it is working on new data, so you can identify these zero-day threats. So these are new kinds of threats that even the developer of that particular program that is there, or that particular system that is there, even the developer is not aware about it, and it is vulnerable from its launch, that is day zero, right? So it works very nicely. This unsupervised learning works very nicely to protect us from these zero-day threats. So now when you come to this reinforcement learning, Here, this will work on this concepts of rewards and punishment, right? Just like you're teaching something to a child, right? And or if the child is doing something wrong and he's too young to understand the reason that why it is wrong, so some parents resolve to they resort to scolding, isn't it? So in that case, you can consider that as a punishment so that child doesn't know that he comes to know that I don't have to repeat this because I will be punished, right? And if he's doing something right, then they might give him some toffee, chocolate, these things, right? So in order to receive that reward, somewhat bribe they may give him, right? Though some people they don't resort to these methods, they don't agree with this. But yeah, you do perform this rewards and punishment with child so that you push him to do the right thing and you sway him from doing the wrong thing, right? So similarly, in our machine learning algorithms, we have something known as a reward function where you have to reach a particular baseline, right? And through coding, if we have trained the model, if that model is getting wrong output, so then we reduce this function over here, right? We bring it down. And we have given this machine learning model one task, that is you have to reach this particular level here. And to reach that particular level, it will always look for more rewards. So that reward function will be increased whenever that machine learning model is giving the right output for that data. Yes, so this is what. So if I want to summarize, so supervised learning is you're working on labeled. There is a human operator that is writing ones and zeros for each and every data. Unsupervised, you're working completely on new data. And in reinforcement, you have this concept of rewards and punishment, right? For that particular function. So even lots of this AlphaGo, that game is there, or chess, lots of games, and even robotics, they are using this reinforcement learnings. In our cybersecurity applications, they are used for autonomous security responses. Okay. So these are your types of learning: supervised, unsupervised, reinforcement, and these can be applied both for machine learning also, and all these three can be applied into deep learning also. And deep learning, as we have already discussed in that previous slide, when we are using artificial neural networks, that is deep learning. Okay. So now, when your most simplest type of deep learning is your perceptrons or feed forward neural networks. Okay. And then you have your convolutional neural networks too. So these are mostly used in your image recognition tasks. Okay. So in cybersecurity, where can this image recognition help? Obviously, in your user protection, that is there. In your access control part, that is there. Facial recognition, there we can apply this, isn't it? Attackers are using this to bypass captchas. Okay. And this terms technography, hiding data. So is it possible, like, you can even hide malware inside images, isn't it? So we can use these CNN models to even detect malwares. Okay. Okay, so then we have our transform. So this chat GPT, or all of you have heard about this, Claude, Grok, all these large language models are there. So what is the heart of them? What is the technology behind them? That is transformers. So this transformers is also a type of deep learning model. Okay. Now here in AI, you have another field, that is your natural language processing. So whenever through machine learning, you're performing these kind of tasks where you want your model to read that data, right? Just like how humans read. So we can use natural language processing for that, right? So we'll study about our traditional NLP methods, we'll study about modern NLP methods all in the course. And then using this natural language processing, obviously wherever you have text data, that will help you there, isn't it? It will help you in your threat intelligence analysis. So as you know, you you visit various feeds, various magazines, various websites where you gain this threat intelligence analysis. If you want to know about the TTPs of the attackers in that way, if you want to summarize these texts, that it can be used for that. Or if see manually in your SOC, like SOC analyst is there, L1 SOC analyst, he will have to read all those logs manually, even if there are some interesting fields there. So, but still there are many, right? So instead of manually doing this, we can assign this task to AI through natural language processing. Okay. So this is the advantage of using NLP here. Then we also have this generative AI. So your LLMs, they come under this. And apart from these large language models that generate this text, you have these diffusion models that generate images. And the most interesting thing that we see here are your generative adversarial networks. So these, like deepfakes, you must have heard. So these GANs are used to create deepfakes, voice cloning, all these things can be done. And it can even help to train the models by creating synthetic data sets. Synthetic data sets can be created here. Okay. So how this generative adversarial network is working? You have this real world data here and you have a generator neural network. So this generator is also a neural network and this discriminator is also a neural network. So this generator network sees this real world data and tries to copy it. Okay. So then this real world data is also fed to the discriminator and the generated data, that is this copied data of this real one, is also sent here, right? And then this adversarial game takes place here. Okay. So you're combining this this is checking this discriminator will check whether this generator is able to create the real data or no. So if it is not able to create the real data, a feedback will be given, okay, this much is lagging behind, right? This process will continue as long as the real data and generated data are similar to each other, right? So this technique can also be used for performing penetration testing on AI systems, because even attackers are using these methods to fool these machine learning and deep learning models that are present there in our organizations. Okay. So now we'll just quickly, before going to the course modules, we'll just quickly see this benefits of AI and cybersecurity. So you have this real-time threat detection here, because obviously you can monitor the traffic in real time once you've placed the machine learning, once you've integrated with your SIEM tools, right? It can identify that unusual patterns. It can flag deviations immediately. So when you look at these benefits, you just have to remember two things. One is your anomaly detection, and one is your behavioral analysis. Right? So using all these things are possible, right? So you can automate your incident response. So not just the traditional rule based one, but here automation as in it is learning with new data too. So that's why you have more automation here, right? This is different from your traditional programming or rule based automation. So you can trigger predefined responses, minimize the damage window, neutralize the threats swiftly. Then you have enhanced accuracy and reduced false positives. Okay, so this false positives one will depend on the training data. If training data is not proper, then you will have even more false positive, right? So it is a double-edged sword. Then you can perform predictive analytics, because you're not just based on signatures, right? If you're finding out new malwares, so you're not just doing signature based analysis, you're doing behavioral based analysis. So based on those indicator of compromises, you can work proactively, right? That's why predictive analytics is possible. Then obviously you'll have improved threat intelligence. We have seen how we can use NLP to read that threat intelligence feeds. Okay. Then using all that what we have studied in our previous slide, you have increased efficiency too, right? Scalability is also there because you can process large amounts of data in real time, not just small, and it can adapt to your growing. So because it can work on new data, it can work on new types of attack, and growing organization needs to, right? And it maintains reliable monitoring. And again, new data means adaptive learning too. Continuously learns from new data, updates understanding of normal behavior, evolves with emerging threats. And using all this, you can even reduce that cost because you have reduced that manual oversight, you have minimized the damage costs, and you can allocate the resources strategically. And incident management is also more enhanced when it comes to our benefits. Okay. Now let's quickly go through these challenges here. So as I mentioned, everything. So you must have heard this term in for your large language models too. Garbage in, garbage out. So if your data quality is garbage in itself, so your models won't work properly, right? So that's why we are all these organizations, they are dependent on this data because it is fueling them. It is the new oil, right? You need proper data. And again, if there is bias in your training data itself, your model will also generate bias. So there are lots of documented cases where, like, people of certain races or certain genders, they are misrepresented in the training data. So when you see, try to identify them with biometrics, so the output, like, it is not satisfactory for them, right? And not just this social causes, even this can be applicable even for network traffic. So say there is US here. Yes, this is part of governance too, as you can see here, regulatory and ethical concerns. So in our course, we have a part of one module. So there are 14 modules. So little bit we are even discussing that. So we have tried to cover everything in our course, though it is mainly focusing around machine learning and deep learning. So you'll see that in the next slide. You'll get the complete idea of our course here. So yeah, we are even because this is a challenge. So we want to implement. We are implementing our ML models and deep learning models holistically. So we will even take governance into account, right? So I was explaining about this. If your network traffic, say if US is blocking some kind of traffic from China that way, or it has trained, so you have trained your model to believe that traffic coming from China is malicious. So if even a normal traffic is coming in from China to the US, they will flag a normal traffic as malicious, right? So that bias will exist in cybersecurity too. Okay. Then you have these adversarial attacks. So when we were discussing about generative adversarial networks, that how that adversarial game was taking place, how your generator was trying to fool your discriminator. So using that similar process, what these attackers do, they try to fool the machine learning models. So say if there is a network anomaly detector integrated in a SIEM. So these attackers will try to fool this particular model, right? Using the same GAN techniques. So we will see this too in our practicals in our course, that how attackers are fooling this. So that's why we need to perform this pen testing, whether our models are robust enough, right? So they manipulate these inputs to fool AI models, and AI may fail to detect or misclassify malicious activity. So sometimes what we can do, if that AI model is there, we can even introduce some noise into it. So from outside, they will seem the same, but the output will be completely different. So it is very easy to fool these sentiment analysis classifiers, right? So we'll see that later all in that course. Okay. So now in our AI, you have this, you must have heard this term explainable AI, XAI. So our AI systems need to be explainable too, right? Because 2012 onwards, like once AlexNet became a thing, black box nature started, right? Because we can't figure out inside that what all is going on in this. So that is one issue too. Then you're using like Nvidia, they have invested so much in GPUs, so much amount of processing power is required. So that is, it is very resource intensive. That is also there. Then privacy and data leakage is also there because you have this technique called as model inversion, where you can leak all the sensitive data or any data that is present inside that model, right? That's why we say you should not enter your sensitive data inside the any LLM that you're using. Okay. Then you also have this hallucination. Though even humans hallucinate, sometimes it may happen with you that you are confidently saying that okay, this is the right answer, and if someone is trying to correct you, still you're not paying attention to them. But since they are trained on humans only, they are just like humans, so they will also hallucinate, right? So now, so in order to avoid this, we go for techniques such as retrieval augmented generation, RAG techniques are there, right? Then all these are our regulatory and ethical concerns, as you rightly pointed out. Okay, so now we'll deep dive into our AI powered cybersecurity domains. Okay, what all we'll be studying in the course. So the course, it is designed in such a way that your initial two classes will get you in touch with all the foundations that you need for Python programming, because we are working with machine learning algorithms, isn't it? So you need to be well versed with this, but keep in mind, you don't need to be an expert in Python programming. You just need to know how to read the code. You need to know the important terms and terminologies. Why I'm focusing on this? Because we will teach you how you can use AI to create these codes, right? But AI is not a magic. It won't happen in itself. You need to know you need to know these important terms and terminologies first, and you also need to know how to read the code. Okay, so in our initial two classes, we'll just give you this introduction to AI, all the introductory concepts you need, and we'll get everyone on page with the cybersecurity terms and terminologies that we need, and side by side, so that we start practicals from day one itself, we will incorporate learning of Python with both of them, right? So these are our foundational modules. Here, like we'll cover all those libraries that you require for AI. So for ML libraries like scikit-learn is more than enough for that. Then basic data science related ones are also there, that are pandas and your matplotlib, seaborn for visualization, and numpys are also there, right? And for your deep learning, we'll go for TensorFlow, Keras, all these we'll learn. In your natural language programming, we'll learn this NLTK library for your natural language processing. NLTK library is there, right? Gen AI, we have Beautiful Soup library. Okay. Then, so that you get familiar with the command line interface too, we will do coding in both. We'll use both Kali Linux. We will create a virtual environment, VNV, and use it on Kali Linux itself. And we are also going with Google Colab, because this deep learning, especially these deep learning machine algorithms, they are very resource intensive. So why not use this cloud-based Jupyter notebook, right? We'll go for Google Colab too. Okay. I'll also show you the new latest things like Cursor. So Windsurf is also there, but I find Cursor better, Cursor AI. So then once we can complete our foundational modules, We will one by one go to supervised learning, then unsupervised learning. So we'll see all about supervised machine learning, and we'll see how classification and regression problems can be solved. Like when you want to classify something, give the probability of something, or regression when you want to say where that things lies in that statistical line, right? We will study about them, and all this we will do. We will even leverage AI. We will leverage AI tools, that how we can learn them better. Okay. Then we'll see that how we can collect data, because in that machine learning life cycle, you know that data collection is that first part. So we'll see how we can do that network traffic monitoring and log collection. Okay, and how we can convert these. So our second step in our learning life cycle is to pre-process the data, right? Performing feature engineering techniques, normalization. So you have to convert the network logs into data set, that we will see here. Once we have learned with can people without programming knowledge start with this Python programming? How easy? So see, in GRC, though you're not directly working with tech, you need to know things from a more broader point of view, isn't it? And especially this GRC, like you're transitioning to AI related things too, isn't it? You have your AI risk management framework, you have your ISO 42001, that is also there. So if you know the technicalities behind it, it will be better for you, right? And if you're asking about Python programming, you don't need to have that background, because we will cover it from the beginning itself. We'll tell you all the terms that are possible. Though if you have taken a basic course, say in your school time, your 11th or 12th class, or in your engineering, like first year, if you have studied, so that will be beneficial only. But even if you have no background, if you are willing to learn the important terms and terminologies behind it, and you know how to give proper prompts, then you don't require prior coding knowledge, right? So that is it from. So I will come to this programming one later. Also, we have this prerequisite skills there. Okay. I will come to the job scope too. So first, let me cover this modules part, then we can discuss that. So then this practical will perform once we know how to do this pre-processing part. We'll see how we can use that data set to perform this spam phishing detection. Okay. Then we have to analyze our results too. So for that, we'll see how we can use these classification reports and confusion metrics to analyze these and further fine tune them. So our fine tuning aspect we will cover in this module with unsupervised machine learning. We'll see how we can fine tune them. We'll see various unsupervised machine learning models. So here in our supervised also we'll see various models, various algorithms, like your logistic regression. We'll see naive Bayes is there, right? These are some of the models that we'll see. Your decision tree is there. Okay. Here we'll see k-means clustering. We'll see random forests, right? These are just some of the models amongst many others that we'll see here. Then we'll study this clustering algorithms in detail. Then we will perform this practical. We'll create a working model for network anomaly detection. Then now that we have studied about lots of unsupervised and supervised different learning models we have studied, we'll see in which kind of scenario, which kind of model should be used. So see, all these things while you're auditing, when you are in your GRC teams, so these things will help you only, isn't it? If you know that how, what has to be done there, right? So then, and of course, if you are working with SIEM tools directly, if you are a cybersecurity analyst, these will directly help you. Okay, so we'll see that practical will perform botnet detection. We'll see how we can conduct and even detect DOS attacks. We will collect that data and we will do a new kind of DOS attacks, and we will see that how our algorithm is working. So this name of this course is AI powered cybersecurity. So I will show you in the website also later. Like if you go here, you can go to this courses part on InfoSec Train. If you select these courses offered by InfoSec Train, this particular one, AI powered cybersecurity training, or even you can go to these new courses. In the second one, you'll see here AI powered cybersecurity training, right? Mastering the future. So you can find this here and you can talk to the respective sales executives. So we will also see how we can design an IDS, intrusion detection system, from scratch. Okay. Then now we have covered the basics, that is our supervised learning and unsupervised learning. So auditing is like, just in this in our last module, you'll see when we are implementing AI security controls, there will just briefly touch upon it, right? Just briefly touch upon it, not an entire. So it won't help you completely. Like if you want to learn everything about AI auditing, it won't help you much with that, but it will definitely, it will cover it, and it will definitely give you the knowledge from where you can learn about that more, right? So it is mostly focusing on the technical aspect, your machine learning and deep learning here, right? So now once we have covered supervised and unsupervised, you have these neural networks. We'll jump to neural networks, and because your deep learning is utilizing these neural networks. So fees, so this course will be of 40 hours, 40 hours duration, right? And fees that you have is, you'll have to contact your sales representative, right? You'll just, as you can see this over here. So right now, if you see this market also over here related to AI and cybersecurity, you won't find any explicit certifications. Here, you'll see people only with their custom courses everywhere. So just related to governance, AI governance, there is one, but for this, for our technical aspect that we have, we currently don't have any certification in the market. So I've pasted this feedback form here. You can just give the feedback. So yeah, we'll see here in our neural networks, we'll see about this perceptrons, the basic unit that is there. We'll see how these are working using these activation functions and propagations. Then we'll see how we can build these multi-layer perceptrons. And using this, we'll see it in action by building a spam detector. Okay, then we'll see all different deep learning algorithms that we discussed in the flowchart earlier in detail here, and we'll see it in action through this handwritten digit recognition program that we have. Okay, then now we have studied all the basics type of learning. We'll see how we can protect our endpoints, right? So we'll have that malware detection will also be there. We'll see different static analysis there, static malware analysis, signature detection, rule-based detection using Yara rules, and P file headers also. We'll see that how we can utilize them, how to build a practical on malicious URL detection too. That will be done here too. Dynamic behavioral analysis will create sandboxes, will show you how we can perform dynamic behavior analysis too. And then, as we have seen here, you can detect using convolutional neural networks. You can find out malwares and images too, right? We'll perform that practically. We'll do this project here. Okay. So that malware that changes its characteristics. So it is very tough to detect this. So we will even see that how we can detect it using these hidden Markov models, right? These are also a type of your neural networks. Okay. Then, as I told you, we'll also study about natural language processing, right? So we'll see all these basics behind NLP, that is your tokenization, right? How you're creating various tokens, you're breaking down those words, right, to process them, finding out features within them through this lemmatization, removing all those stop words like in, as, is, but. So these are not required, right, for identifying the patterns we have there. So these are some of the things we'll see here. We'll see various NLP techniques. So be it bag of words, TF-IDF, word to vec. So these are also used in your RAG for because this is effective against hallucinations, right? AIs are hallucinating, so we can see that how we can use these techniques for that. Then now we have given our AI system the power to read. We will see that how we can create a program for detecting, for reading the system logs and detecting threats within it, and also reading the mails. We can make it read the mails and detect it for phishing, search for phishing or spam. Okay. Then you have your IAM and data protection too. So in this UEBA, this is a very important thing here, user entity behavior analytics. So will all these users, they have a kind of behavior, a baseline behavior. So if any change in that, our systems can identify it, right? We can create programs for determining password strength. Okay. And see, all of you have a particular way of typing something, isn't it? You have a particular way. So if you tell your password to someone and someone tries to type it in, he'll be able to log in. But what if we implement this keystroke recognition authentication? So then it will only be able to, your password will only work if you are typing it, if someone else is typing it the way you type, right? So how will the attacker come to know how you type, right? So this is a program that we'll be working on. Then, of course, you have this usability versus security issue, right? Though, like nowadays, you have the zero trust also where you're continuously verifying, right? But due to that, our usability might go down, right? So, how to handle this usability and security aspect? So, that part also will be covering. Then we have another practical on facial recognition. Then we have practical on machine learning based steganography for protecting our data. Okay. Then see, who's they were talking about auditing too. So we are covering HIPAA over here. So if you have this knowledge of how to identify, how to explore and visualize these HIPAA breaches technically, right? Won't it help you in your auditing? Right? You can use this knowledge you learned over here for your PCI DSS also, your SOCs also, all different frameworks. Okay. So then we'll also see that how we can integrate it with our SIEM tools. So we'll see about elk stack here, right? Through that, we can see how incident response, threat intelligence, and forensics will take place. Okay. Then we have this most interesting part of all of those who are interested in penetration testing. We have this topic for you here, generative adversarial networks, right? Here we'll see all the basics about this. So we've already discussed a bit that how it works here. Then we'll see how we can perform pen testing with this, and then how we can bypass malware detectors using these malware GANs, right? And we'll see how we can do that using reinforcement learning too. Okay. Now, this is also there. You have your adversarial attacks on artificial intelligence. So we'll see all the OWASP machine learning top 10. Okay, what are the attacks there and the most common types of attacks, that is your evasion attacks. So this thing where you're fooling these models, these are part of your evasion attacks only. Okay, then we'll do that poisoning attacks also, that how you can poison the data set, right? If you poison the data set, you can manipulate the outputs here, right? And this very dangerous thing is there, model extraction, right? Also called as model inversion. So here in this particular thing, you are extracting all the data that is present inside the model, right? So all these techniques we'll see how it is done, and we will also see the mitigation techniques for this, right? Because if we want to implement these AI security controls, we need to know how to mitigate it, right? We'll see your entire data life cycle for security. Will see how you can build that secure AI model, because once we know the mitigation techniques, we can develop secure AI models. Okay, AI system monitoring and auditing is a part. We'll touch up upon it, right? AI governance is also there. We'll discuss this next. AI risk management framework, ISO 42001. This will be discussed, and MITRE Atlas will also be discussed. Just like how you have your MITRE attack framework, here also we'll see that how that AI. So how your adversaries are using AI and how we can look at their AI TTPs over here, right? We have to study MITRE from an AI point of view here. So that we'll cover here. And this module that you see on generative AI, this will be covered with each and every module. So as we study about networking, as we study about endpoint protection, we'll see how we can leverage generative AI, how we can do those things through prompts also, right? So this was a bit about our course structure, right? So we can just end with this machine learning life cycle here. So you like, I'll just give you a sneak peek here of this code. I have this DOS program here that I've made. So here, as you can see, your first step is always to collect the data. So I'll show you that how I've collected that data in our class, right? I had done that data collection and I fed it over here in this CSV file. Okay. Then our next step is to label this data. As you can see here, we label this. So normal traffic, so this is our normal traffic file, this is our multiple DOS. So this is our DOS traffic file, right? So we are labeling DOS as 1, normal traffic as 0. Then we combine the data sets and we are performing feature engineering, right? Things like calculating the time difference between the packets per second, identifying whether it is UDP, TCP packets to detect UDP flooding, TCP flooding. And if we are performing DOS attacks, then TCP flags, they have data with them, right? So we will identify that pattern too. So can you see all these steps here? So if you look at this machine learning life cycle that we have, so first we collected the data, right? Then we are preparing the data. In preparing the data, we are doing this pre-processing. Apart from pre-processing, we are performing feature engineering, right? So when we were labeling the data as ones and zeros, right? That was our pre-processing part, example of that. Feature engineering, when we were taking out the features like packets per second, data with TCP, right? So that was our feature engineering, okay? Then we have another step here in preparing the data, that is our normalization. So in normalization, we are creating our data such that it will lie between ones and zeros, because you will have some text data too, right? So if you know even the basics of programming, that how your if else statement is working, if you're familiar with it, though we'll cover these basics again, right? For them it is perfect. You don't need to be an expert in coding. Why I'm repeating this again and again? Because I will show you how you can code using prompts, how you can debug programs using prompts. If you look at this Google Colab, so this tool that I'm using, this is Google Colab. So if you look at this over here, right, you can even code it, right? You can add a code cell. If there is some error over here, you can use this Gemini over here with this Google Colab, right? And not only this, in Cursor, you can do it at an even better way, right? So in this code, if I show you this next part, so this normalization part is there, converting it into ones and zeros. So this is our normalization step that we have here, right? So all this will be covered later, though till now these functions, what are these, what they stand for, you might not be able to understand, but once we go even through 2 days of our course, you'll be in a position to read this and understand this code, right? Then we are saving this preprocessed data in this particular data set here, right? Named preprocessed traffic data.csv. Okay. Then now next what we need to do, see our model over here. We are choosing a particular model. What kind of machine learning model we need, right? Then after we have chosen the model, then we train the model. So if you see our code, we are choosing a model here, then we are training this. So this particular, so see, we don't need to code the model, right? We are not data scientists here. We are cybersecurity experts. We are using AI to make our work easier. So everything is available inside this library. So I'm using this decision tree and random forest just to see which one is performing better for detecting these DOS attacks. So this is present in this scikit-learn library, right? Which we'll see in our initial classes itself, right? From this we have imported this model, and you in this scikit-learn library you have another thing here, that is your classification report and confusion matrix, right? Using which we can analyze this data, how it is actually performing. Okay. Then you also have this train test split. Can you see this? You're importing this train test split from this scikit-learn model. So using this, so can you see this train test split? So I'm using this train test split function here, right? So all this code, you don't even you have to write this. You just have to give the prompts and it will create this code for you. But you need to be in a position to understand what it is doing. You need to be in a position to debug it. Though you can even use AI for debugging, but since that's why I'm saying you just need to focus on the terms and terminologies, right? Which we'll be covering. Okay. So we are performing this. So why train test split? Because you need to split like around 80%, that data set that you have, 80% will be used for training it, and 20% of that data will be used for testing it, whether it is working or no, right? Then after you have using this decision tree classifier, see, just this simple command is there to train that model, right? Because everything, the depth of that command is there in that library, right? Here we are just calling the function, isn't it? And here we are calling this random forest machine learning model, right? Here we are calling this decision tree machine learning model, right? This decision tree is supervised learning. Random forest is a ensemble method which classifies, which includes various different types of machine learning models. Okay. Then you save this model, then we will evaluate our decision on that testing data set, right? We are evaluating for decision tree and random forest and created the confusion matrix report. So as you can see here, this decision tree accuracy. So if we run this code over here, it has provided this accuracy is 99.5 for decision tree, 99.8 for random forest. Right? Can you see this? So this classification report is also there. Exactly. So these are all your things it has identified. So it has there are 613 instances of normal traffic. It has identified 612 of them. 588 DOS instances were there. It was able to identify 587. So this is what our diagram here is telling. Okay. Now that we have trained our model, then so see if our accuracy was low, say 95%, right? Because we always aim for high accuracy, right? Or if it was in 80s, then we would have performed this fine tuning of that model, right? Then we will evaluate and test it on new data. Okay. So in this second part of the code, you can see I have added this new data file here, right? This DOS new data test.csv. I've loaded this here in the side, right? And I'm working with this new data. And again, the normalization, pre-processing, all these parts, feature engineering parts will take place on this data, and we will test it using both our models. So this data contains new types of DOS attacks, right? And let's see whether our model was able to detect it. So as you can see here, DOS attacks have been detected, right? It has detected the DOS attacks here. And see, you can see that how many are DOS, how many are normal, right? So our decision tree on new data, it was not working, that though it has detected majority as DOS, but our random forest model here has detected even more DOS attacks, right? It is working even better in this visualization. So these are the steps here. So now it is working on new data. Then we will apply these ML ops, right? We will see how we apply these ML ops where we deploy the model, monitor them, right? Right? All these things are there. How we can deploy them in the real world. So this is our complete machine learning lifecycle about which we will see in detail in our course, right? Now, the question is, who is this course for? So, as I've told you that what you need to know, you just need the basic cybersecurity terminologies. If you're familiar with that, this is more than enough for you, right? And if you have studied programming language at any point of your time, doesn't matter which programming languages, if you know a bit about algorithms, you can catch it pretty easily. And even if you have not done this, we will be introducing the terms because we are beginning from the starting, right? And we are also leveraging AI. So if you know how to give the prompts and how to read the code, which we will cover, you can easily do this. Okay, so I'll address all your questions that you're giving in the end once we just go through these prerequisites and industry demands. Okay, so now all those who can take, if you're working in any domain within cybersecurity, this is for you, be it whether you're fresher or experienced, right? Because AI is a new thing, so even freshers have to learn it, even though all those who are experienced, they also need to learn this, right? And most of all those who are passionate to combine this AI with cybersecurity, this course is for you, right? So these are some of the prerequisites we have. Now, why take this course? So if you have gone through this World Economic Forum's report, right? Future of Jobs Report 2025, if you've gone through this. So you know the fastest growing jobs that are there. So you can see in your first number, your big data specialist, fintech engineers. Then at third number, you have AI and machine learning specialists. And in fifth number, you have your security management specialists, right? So imagine if you combine both of them. And so these are jobs. When I'm talking about skills, so they have started considering AI and cybersecurity as a skill that every technical professional should know. So if you look at this networking, so whether you're a developer, whether you're in cybersecurity, we say networking is your prerequisite. You should know about computer networks, right? And through this advent and importance of cybersecurity, so see Cisco was a networking company, but it is focusing now more on cybersecurity, right? So networks and cybersecurity is a must skill that you must have along with AI and big data skills, all which will be covered in this course. Okay. So now now these topics like this we had already covered your industry demands, that how you can use it, how attackers are using, how AI is a threat to, and how you're using it for defense too, right? IAM, that UEBA that we studied, user entity behavior analytics. So this trend is there, this trend is there in that industry. You're going for this. SOAR, security, orchestration and automation, right? And response. All this you're automating it. So how we can automate incident response. All these are industry demands, right? So if you have these skills, this will help you only. Human-centric challenges are there. Then of course you're using AI systems, so regulatory shifts will also be there too, isn't it? So once you know the thing technically too, so applying them from a governance point of view, from an auditing point of view is always better, right? Because no one can fool you then, right? Though if you have only the surface level knowledge, um, though though be it wide level, though you know everything about cybersecurity, but if you know the technicalities behind them, so the auditing that you'll conduct, that will be obviously better, isn't it? Then these are some of the job roles that will arise in the future. So they've already started arising. So you have your AI cybersecurity analyst, machine learning engineer from a security point of view, then security automation architect, cybersecurity data scientist, SOC analyst with an AI specialty, cybersecurity risk assessor, right? From all your GRC teams. This is also there. Okay. So when it comes to this, the AI, both things are there. Using AI with cybersecurity, right? And making AI systems more robust, making AI system more robust, right? Both these things are there, which will be covered here in this course, right? And these are also your job openings, right? They are looking for people who can use AI for performing cybersecurity tasks and also secure their AI systems because as you know what the threat landscape is, right? You know what a attack surface is. So AI in itself is a new attack surface. So you need to know how to secure this too. Okay.